Hello! We're up for a new type of segment relationship inside of a circle. So on this one, we're going to have two secants intersecting outside the circle. Whoa, right? Okay, and I'm going to call this the secant-secant relationship because it involves two secants. So if that helps you, we got the chord, and then we got the secant-secant. If it doesn't help you, you don't have to write that down or you don't have to use it, but for me it helps, so I use it. But anyway, so let's see what happens when two secants intersect outside of this beautiful circle. Let's go back to that Prezi that you guys adore so much. All right, so secants intersecting outside of the circle. Guys, so if two secants intersect on the outside of a circle, then the product of the sum of the two segments of the first secant and the external segment equals the product of the sum of the two segments of the second secant and the external segment, which you're probably like, this long, like I started zoning you out like 2 seconds into that. Okay, I know that does not probably make any sense. It's hard to verbalize this property, so I did my best. But I think this little diagram down here will make it a lot more clear. Okay, so basically, you guys, if you start with the secant, okay, you're going to start with the piece of the secant located outside the circle. So the segment that's outside of the circle on my first secant is BC. You're going to multiply that to the length of the entire secant segment, okay, which the two segments within secant AC are AB and BC. So you're going to add those two together. So you basically do the outer segment times the outer segment plus the inner segment equals the same thing on the other one. So the outer segment, CD, times the outer segment plus the inner segment. So outer times outer plus inner equals outer times outer plus inner, if that helps. Okay, so basically you start with the outside segment and multiply the two pieces of the secant together. Okay, so that's the idea that we're going to be using when we solve. So let's get going. Okay, so on this one we got two secants, which I'm going to write it down so we can reference that later on. Okay, so our two secants are, don't do that. Our two secants are segments R to the T and R to the Q. So RT and RQ. Okay, and now let's set this bad boy up. So I'm going to start with RT. Okay, so we're going to start with the segment on secant RT that is located outside the circle. What part of the secant is located outside the circle? It is RS. Okay, so this right here, which let's see here, I'm going to use this color. All right, so we're going to have RS, that's the part on the outside of the circle, times the length of the whole secant, which are these two parts added together. I'm going to add the two parts of the secant together because that will give me the length of the whole secant. Okay, so the two segments within the secant are RS and ST. So I'm going to add those bad boys together, RS plus ST. Okay, and that will equal the outer segment on my second secant RQ. So which segment is located outside the circle on secant RQ? It is RP. So that's going to be RP, which I did not plan ahead on this like I normally do, running out of space. So RP, that's a parenthesis, RP times the length of the whole secant, which is RQ, and the length of the whole segment is broken down into these two segments. So RP and PQ. So I'm going to add those bad boys together. So RP plus PQ. Sorry, I know that's really hard to see. RP plus PQ. Okay. All right, let's start filling in values. This is so much fun. Let's go. So I'm going to fill in these values. I'm going to start over here to make sure I have enough space. Let's do this thing. All right, so RS is 4, so it's going to be 4 times RS again, which is 4, plus 6, which is ST. Okay, which equals R to the P, okay, which RP is 5, times the length of the entire secant, which are these two added together. So RP is 5 plus X. Look at that. And all we gotta do is solve this thing. So let's get going. All right, so this 4 is located outside of a parenthesis, and same with this 5. What do you do with a number located outside of the parenthesis? You do distribute that thing, so let's distribute that thing through. Bam, bam. So 4 times 4 is 16, plus 4 times 6 is 24, which will equal 5 times 5, which is 25, and 5 times x, which is 5x. All right, let's solve this thing for x. So 16 plus 24, that's going to give me 40. Okay, and that will equal 25 plus 5x, which I'm running out of space like normal. It's okay, guys. I'll make it work. All right, so I need to move 25 to the other side. How do you move a positive 25 to the other side? Look at that rhyming. You do subtract that bad boy on both sides. Okay, so 25 minus 25 cancels and turns to 0. 40 minus 25 will give me 15, which I'll double check. Yep. Okay, so we're going to have 5x equals 15. I'm going to squeeze it over here. 5x equals 15. All right, and then simply I need to move 5 to the other side. How do you move 5 to the other side? You do, in fact, divide both sides by 5, since that's secretly multiplying to the x. Okay, which 5 divided by 5 will cancel and turn to 1. 15 divided by 5 will be 3. So I'm going to write x over here. X equals 3. Shazam! Look at that. Oh, man. But we are not done. The directions say to find the value of x and z. This problem doesn't have z, though. That's going to be on example 4, so wait for that. And the length of each segment. Okay, or secant. Whoa, apparently I can't read. The length of each secant segment. Okay, so now we're going to find the length of r to the t and r to the q. All right, let's get going. Okay, so I'm going to break down these 2 segments into the 2 segments that lie within it. So which 2 segments are within RT? They are RS and ST. So that will equal RS plus ST. All right, let's start filling in some values. Okay, so we're going to have RT equals R to the S and ST, which RS is 4. Okay, so I'm going to have 4. And ST is 6. So I'm just going to add 4 and 6 together, which lets 4 plus 6, you guys. Yay, it is 10. Nice. Or should I say nice. All right, so RT is 10. Now we just got to find RQ and we'll be done. Okay, so which 2 segments make up segment RQ? They are, in fact, RP and PQ. So let's break it on down. RQ equals RP plus PQ. All right, let's start filling in our values. Okay, so RP is 5. Oh, forgot my equal sign. Gee willikers, Miss Long. All right, so 5, and then PQ is X. All right, and now that I know that X is 3, what can I do with 3 to find RQ? I can substitute that bad boy in. So I'm going to replace X with 3. It will transform into a 3. So I'm going to have R to the Q equals 5 plus X, which is now 3. All right, and guess what, you guys? 5 plus 3 is 8. Oh, man. That's how we do it, you guys. Nice job. Nice job.